So friend, today we are going to discuss the new topic of metric space. It is the limit point in a metric space. Now see, what is the definition of limit point in a metric space, or how to define the limit point in a metric space? So see, this is the definition. Let Xd be a metric space and A it is subset of X. Then X belong to X, it is called the limit point of set A if every open sphere S with center at X and radius R contains infinitely many points of A other than X, then this X it is called the limit point of set A. Now see, what is this definition? For limit point, first of all we required some metric space. This is the requirement for the limit point. We required some space capital X. We required some subset A of this capital X, and we required some point X which is the element of this space. Now see, these are the requirement for the limit point. What is the requirement for limit point? We required some metric space, suppose this is the X. What is the second requirement for the limit point? We required some subset A of metric space X, and we required some small x belongs to capital X. We required some point which is the element of this space. We required some point X which is the element of this capital X. Now see, this point X, it may be element of A or it may not be element of A. There are two conditions. This is suppose the metric space X. A, this is subset of X, and what is this X? X may be element of A or X may not be element of A. Both the condition. X, it is the element of A or X does not element of A. But definitely this X, it is the element of this capital X. So see, what is the definition of limit point, or what are the requirement for the limit point? For limit point, first of all we required some space capital X. What is the second condition? We required some subset, and what is the third condition? We required some point which is the element of that space. These are the three conditions, or these are the three requirement for the limit point. Now see, what is the definition of limit point? This is the definition. If Xd, if this is suppose the metric space, and if suppose A it is the subset of capital X, then what is the definition of limit point? This point X, it is called the limit point of this set A, means that for every open sphere S with center at X and radius R, if we consider suppose the open sphere with center at X and suppose the radius R, it contains the infinitely many point of A other than this X. Now see, what is the definition of limit point? X is said to be limit point. Limit point means every open sphere it contains infinitely many point of A other than this X, then this X it is called the limit point of set A. Now see, what is the definition of limit point? For limit point, these are the three required conditions. First of all, we required some space X. We required subset A of space X, and we required this point X it may be element of A or it does not the element of this set A. Both the cases. It may be element of A or it may not be element of this set A. Now see what is the definition of this limit point. If we consider this as a metric space, suppose XD, this is the metric space, and we required any subset A of capital X. These are the precondition for limit point. Now what is this X? X, it may be element of A or it may not be element of A. Obviously this X, it is the element of capital X. This is the requirement. X, it should be element of capital X. It should be element of this our space X. Now what is the definition of this limit point? This point X, it is called the limit point of this set A. What is the definition? Every open sphere S with center at X and radius R, it contains infinitely many points of A other than this X. We require infinitely many points. This open sphere S with center at X and radius R contains infinitely many points of A other than this X. Then this X, it is called the limit point of set A. Now set of all limit point, it is denoted by the notation A dash or it is denoted by the notation derived set of A. This is the notation for set of all limit point. Set of all limit point, either it is denoted by the notation A dash or set of all limit point, it is denoted by the notation derived set of A. These are the notation for set of all limit point. Now let us take some example by which we can easily understand this definition, what is the limit of function. So let us take example. Write down the first example. Find the limit point of set A is equal to 1 upon n, where what is this n? N, it is a natural number. See, we are given some set A is equal to set of all 1 upon n, where n it is a natural number, and we want to find out the limit point of this set. And what is our space? Here we are taken the R as a set of a real number, and obviously this A, it is subset of this real number. What is our required space? We take R set of real number as our space, and what is this A? A, it is subset of R. Now we want to find out the limit point of this set. Now if we write, suppose this set A is equal to, now what is this set? What is this n? N, it is some natural number. Now if we put n equal to 1, so this is the first point. Put n equal to 2, so this is second point. Put n equal to 3, this is third point. Put n equal to 4, put n equal to 5, this is the fifth term. Dot 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 1 upon suppose 10 lakh, 1 upon 10 lakh 1 suppose, and so on. So this is our given set. Now see what is the given set. Now see what is the given set. A is equal to set of all 1 upon n, where what is n? N, it is a natural number. Now if we put n equal to 1, then what is this set? 1, 1 half, 1 upon 3, 1 by 4, 1 by 5, dot dot dot. This is 1 upon 10 lakh suppose. What is the next point? 10 lakh 1. What is the next point? 10 lakh 2, and so on. Now if we put suppose n equal to infinity, if we take suppose n equal to infinity, then 1 upon infinity equal to 0, but it is not the point of the given set. This is the given set. 1, 1 half, 1 upon 3, 1 by 4, 1 by 5, and so on. Now what is our given space? Our given space, it is the set of real number, and what is A? A, it is subset of X. Now if we consider suppose this as a real line, this is our given space R, Now if you plot this, suppose this point 1, so this is our suppose the point 1. What is our last point? If we put suppose n equal to infinity, then what will be the last point? 1 upon infinity, it is 0. So last point maybe it is 0. So this is our suppose 0. 0, that is not the element of the given set. Now this is our first point 1. 1 half means 0.5. 0.5 means this is the position of 1 half. 1 by 3, so this is the element 1 by 3. 1 by 4, so this is the element 1 by 4. Now this is suppose 1 by 5, dot dot dot. Now if we increase this term 1 half, 1 upon 3, 1 by 4, 1 by 5. Now suppose this is 1 upon 10 lakh. This is 1 upon 10 lakh 1 and so on. This is just increase by 1, 1 half, 1 by 3, 1 by 4, 1 by 5, 1 upon 10 lakh, suppose 1 upon 10 lakh 1 and so on. Now we have to find out now the limit point of the given set. Now see what is the definition of limit point. For limit point, first of all, we required some space. We have taken R as a set of real numbers, suppose this is our given space. What is the second condition? We required some subset. Just take this A as a subset of this R. This is our required subset A, it is some subset. Now we required some element X which is the element of this capital R. This is called the limit point. We have to take the limit point from the set of real number. Set of real number means we can take any number. Real number means we can take any number 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, 1 half, minus 3 by 2. These are the real number. So this is called the limit point. What is the definition of limit point? We have to take the limit point from the real line. Now what is meant by the limit point? What is the definition of limit point? Suppose this is our space. R, it is the given space. We have taken some subset A, it is subset of R. Then what is the definition of limit point? X, this point X, it is called the limit point. Limit point means we have to find every open sphere S which center at X and radius R contains infinitely many points of A other than X, then this X, it is called the limit point of set A. Now just check the element for limit point. Now let us check this element, suppose this is 1. Now check whether 1, it is the limit point of the given set or not. Now see this point 1, this is not the limit point, because what is the condition for limit point? Limit point means if suppose X is called a limit point means we have to find every open sphere. Now for the set of real line, what is the open sphere? Open interval, it is nothing but the open sphere. What is the condition for limit point? We have to find every open sphere which contains infinitely many points of A other than this X. Now let us check whether this X or X equal to 1, whether this is limit point of the given set or not. Now this is not a limit point. What is the reason? Because every open sphere, now this is the open sphere. For real line, what is the open sphere? Every open interval, it is nothing but the open sphere. So this is the open sphere. Now this open sphere does not contains any point of this set A. What is the definition of limit point? If X is the limit point, then every open sphere contains infinitely many points of A. Now this one, it is not the limit point, because if you consider this open sphere, then this open sphere does not contains the infinitely many points of A. So this is not the limit point. So X equal to 1, this is not the limit point. Now X equal to 1 half, now if you consider this next point X equal to 1 half, now again this is not the limit point. What is the reason? if we draw this suppose open sphere means open interval. Every open interval in a real line, it represents the open sphere. So this open sphere does not contains any point of A, so this is not the limit point. X equal to 1 upon 3, again this is not the limit point, because if we consider this open sphere, then this open sphere does not contains the point of A, so this is not the limit point. Check for the next point. X equal to 1 upon 4, this is not the limit point, because if we draw this open sphere, then this open sphere does not contains the point of A, so this is not the limit point. Now if we take this point, suppose 0, it is not the element of the given set, but it is the element of real number. We can take any real number. Now this 0, this is the limit point of this set A. How to show that this is the limit point? If we consider this open sphere, now this open sphere contains these infinitely many points of A. These are the point of A. Point of A means what are the point of A? This is 1 upon 10 lakh, suppose this is 10 lakh 1, this is 10 lakh 2. So this neighborhood contains certain point of A. These are the point of A. So for this point x equal to 0, if we take suppose 0, and if we draw this open sphere, then this open sphere contains these infinitely many point of A. So this x equal to 0, this is called the limit point. So what are the limit point of this set? Limit point of this set, it is nothing but the singleton 0. Just it contains one element. Now suppose if we take these other element, suppose if we take x equal to 2. X equal to 2, this is not the limit point. Because if we consider this open sphere, then this open sphere does not contains any point of A, so this is not a limit point. If we take suppose this point x equal to -1, we can take any point of real number. If we take suppose x equal to -1, and this is the open sphere for this point x equal to -1. So this open sphere does not contains any point of A. Point of A just it is lies between 0 and 1. So this open sphere does not contains any point of A, so this is not the limit point of A. There is just one limit point, x equal to 0, it is the limit point. So how to show that it is limit point? Suppose if we consider this 0 point, just draw this open sphere, then this open sphere contains the infinitely many point of A. So x equal to 0, it is the limit point. So set of all limit point, it contains just one point, it is the singleton 0. So see what is this example? A is equal to set of all 1 upon n, where what is n? N it is a natural number. We want to find out the limit point. There is just one limit point, x equal to 0, it is the limit point for this set. Now let us consider the second example. Find the limit point of rational number. Now if we consider A as a set of rational number and just consider R as a set of real number, this is our space Q, it is subset of this real number R. Now Q, it is the set of rational number. Rational number means it contains 0, it contains all the positive number, it contains all the negative number, it contains division type of number, it is 1/2, 1 upon 3 and so on. And this is our space, it is the set of real number. Set of real number means up to -infinity to +infinity, it is our space. Now we have to find out the limit point of this rational number. Now see, what are the limit point for the rational number? Now 1, this is the limit point for this set of rational numbers. See what is meant by the limit point? Limit point means if we draw some open sphere, then this open sphere contains infinitely many points of this set A. Then and then it is called a limit point. Now this one, it is called a limit point. Limit point means this open sphere, it contains this infinitely rational number. In between this interval, suppose we have taken R as a set of real number, and what is the open sphere for the real number? Open interval, it represents the open sphere. So if we take suppose x equal to 1, if you consider this point 1, then this is the limit point, because if we consider this as an open sphere, then this open sphere or this open interval contains infinitely many rational number. So x equal to 1, this is the limit point. X equal to 2, this is again the limit point, because if we take suppose 2 point, then this is the open sphere for this point, and obviously this open sphere contains infinitely many rational. What is the given set? A, it is the given set, and it is the set of rational number. So this open sphere contains infinitely many rational number. So x equal to 2, this is called the limit point. X equal to 3, this is again the limit point. If you draw this open sphere, obviously this open sphere contains infinitely many rational number. Rational number, it is the given set. So these are all the limit point. X equal to 1, 2, 3, 4, 5, 6. These are the limit point. Minus 2, this is again the limit point, because if you draw this open sphere, then this open sphere contains infinitely many rational number. So this is again the limit point. X equal to 1 half, this is again the limit point, because if you draw this open sphere, then this open sphere contains infinitely many rational number. So these are all the limit point. All the elements are the limit point. So what are the limit point? Limit points are nothing but our rational number. It contains every number. 1, 2, 3, 4, 5 it is the limit point, 6 it is the limit point, 0 it is the limit point. If you draw this open sphere, obviously it contains the infinitely many rational number. X equal to minus 1, minus 2, minus, these are all the limit point. Now suppose, if we take suppose the irrational number, suppose if we take this root 2 as an irrational number, this is our space. Real line, it is the space. Real line means we can take any number. We can take rational number, we can take irrational number also. Now if we take suppose this irrational number root 2, and if we draw this open sphere for root 2, then this open sphere contains infinitely many rational number. This is our root 2 suppose. And this is suppose the open sphere or open interval for this point. So this open sphere contains this infinitely many rational number, because we know that any interval contains infinitely many rational number as well as irrational number. So every irrational number, it is also the limit point. If you consider suppose root 3, then this is again the open sphere for root 3. So this is the open sphere. This open sphere contains infinitely many rational number. So set of all rational number, it is the limit point, as well as set of all irrational number, this is again the limit point. So union with set of all irrational number. So see, if we take suppose the set of rational number, then what are the limit point for the rational number? Set of all rational number, it is the limit point, as well as the set of all irrational number, it is again the limit point. So rational union with irrational number, it is nothing but set of all real number. So see, we want to find out the limit point for the rational number, and what is the set of all limit point? It is nothing but the real number. Now consider the next example. Find the limit point of natural number. So see, once again I am going to explain what is the limit point. For limit point, we required some space, we required some subset, and we required any point from the space. This point may be present in A, or it may not be element of capital A, both the cases. This element X, this is called a limit point. This limit point, it may be element of A or it may not be element of A. Then what is meant by the limit point? Limit point means every open sphere S with center at X and radius R contains infinitely many points of A other than X, then X it is called the limit point. Now say this is the next example. Okay, consider N as a set of natural number and just take set of real number as a space. Obviously this N, it is subset of R, and the question is find out the limit point of natural number. Now say what is this set natural number? Natural number means it contains the element 1, 2, 3, 4, 5 up to infinite element. Now this is our space R, this is our given space R, and this is the given set 1, 2, 3, 4 up to infinite. So if we draw these elements, suppose this is 1, this is suppose 2, this is 3, this is 4, this is 5 and so on. These are the infinite elements. Now let us check this element for the limit point. Now this x equal to 1, this is not the limit point, because if we draw this open sphere, then this open sphere does not contains any point of this capital N. See what is the definition of limit point? If x is the limit point, then what is the definition? Every open sphere contains infinitely many points of the given set. This condition it is not true for this element. If we take suppose x equal to 1, then this is the open sphere for this point. Now this open sphere does not contains any point of this set. So x equal to 1, this is not the limit point. Now again this 2, it is not the limit point. Limit point means what is the condition for limit point? We have to take every open sphere. Every open sphere contains the infinitely many points of the given set. This condition it is not true for this element. If we consider this open sphere, then this open sphere does not contains any point of natural number. This natural number contains the jumping off element 1, 2, 3. It does not contain this middle element. It is the jumping off element. It is the discrete element. It is not the continuous element. So this 2, this is not the limit point. 3, it is not the limit point, because if we draw this open sphere, then this open sphere does not contain any point of natural number. Similarly, we can verify that if 4, 5 and so on, these are not the limit point. So what are the limit point for this set? Limit point for this set, it is nothing but the empty set. There is no limit point for the natural number. If we take the natural number, then we observe that there is no limit point for the natural number. So what is this derived set? A dash means the set of all limit point. So set of all limit point, there is no element. So this will be empty set. Now consider the next example. This closed interval 5 to 7. Just find out limit point of this set, and again we take this R as a given space, that is the set of real number. Now suppose this is the real line. Now this is our interval 5 to 7. 5, this is suppose 6 and this is 7. Close interval 5 to 7 means we have to take this end point also 5 to 7, and it contains every element, this middle element. Closed interval means it contains all the element from 5 to 7. Now just find out the limit point of this interval. Now see what are the limit point. If we take suppose this 5. Now 5, this is the limit point, because if we draw this open sphere means just take the open interval, because we have taken this real line. For real line, what is the open sphere? Just open sphere. What is the open sphere for the real line? It is just an open interval. So this open sphere contains this infinitely many point of this set. What is the given set? 5 to 7. So if we take this element 5 and if we draw this open sphere, then it contains infinitely many point of the given set. So this is the limit point. 6, it is again the limit point, because if we consider this open sphere, then this open sphere contains the infinitely many point of the given set. So this is again the limit point. 7, it is the limit point. Again the process is same. Just draw the open sphere. It contains the infinitely many point of the given set. So this is again the limit point. If you consider suppose the middle point, Suppose consider this 5.1 suppose. Just consider 5.2. This is again the limit point. If you take suppose 5.2, then this is the open sphere for this point 5.2. So obviously this open sphere contains the infinitely many points. Suppose this is the element 5.2. So this is the open sphere for that element. So this open sphere contains obviously infinitely many points of this set. So every point it is the limit point for this set. So what is the derived set, or what is the set of all limit point? It is itself closed interval phi 7. It is the set of all limit point. Now the next question is find out the limit point for the open interval. Now this is the same question. This is a real line. This is suppose 5, this is 6 and this is 7, and this is our open interval 5 to 7. Open interval 5 to 7 means just exclude these end point 5 to 7. But for limit point, we can take this point also. We can take any element of R. We can take 1, we can take 0, we can take -1, we can take 8, 9, 10. We can take any element for the real line. Now see, this 5, this is again the limit point. If we take suppose x equal to 5, then for the element 5, this is the open sphere, and this open sphere obviously it contains the infinitely many point of this interval of the given set. So this is the limit point. 6, this is the again limit point, as well as this 7, it is the limit point. If we take suppose x equal to 7, then this is the open sphere for this point. So this open sphere obviously it contains, we can check, okay, this open sphere contains infinitely many point of the given set. Take any point in between these 5 to 7. If we take suppose 5.4 suppose. So for this point this is the open sphere. For this open sphere it contains every infinitely many point of the given set. So these are all the limit point of the given set. So what is the derived set for this open? If we suppose denote this set as a A. So what is the set of all limit point? It contains every point. So what is the limit point for this open interval? It is the closed interval 5 to 7. We can take this phi as a limit point, because if we draw this open sphere, then this open sphere it contains the every point. So derived set or set of all limit point, this open interval it is nothing but the closed interval 5 to 7. Now find out this limit point for this interval 5 to 7, half open interval. Again the same, exclude this end point 5 and this is including this end point. Now 5, this is the limit point. Just take this as a real line. We can take any number for real line. Now if we take suppose x equal to 5, then this is the open sphere. Then this open sphere contains the infinitely many point of the given set. So x equal to 5 is the limit point. 6, it is the limit point, because if we draw this open sphere, then this open sphere contains infinitely many. Similarly, we can show for every point in between 5 to 7. So limit point for this set, it is nothing but the closed interval 5 to 7. Similarly, for this set, close at 5 and open at 7, the limit point will be same. It is the closed interval 5 to 7. So this is the same limit point for closed interval, for open interval, and for half open interval. What is the limit point? It contains just closed interval 5 to 7.